All right. Good evening, everybody, and welcome. This is kind of an exciting class and series of classes for this, and you'll have to bear with us because this is new to me and new to my, the setups and everything we're doing. So it may not be flawless, and we may make mistakes, but hang with because we'll all learn together, I guess. All right. So in tonight's class, we're going to continue on with the display table project. Let me go ahead and share my screen, and I'm going to bring some things down here real quickly. First of all, if you go to our website and you go to the training and class review, okay, here's last week's class, and here is the display table file that we drew last time. I've actually edited it, so if you already downloaded it, you want to download it again. So I'll just click on it and download it here now. If it did, I can't tell. Yeah, there we go. It's downloaded. And I have also exported the Conversational Cam Pro file as well. So you can actually download this, which I have done, and I'll show you how that works in just a second. And the question was asked while we're here last week about the feeds and speeds, and I have included the chip load calculator. It's a spreadsheet from Milo. So if you watch that class and wanted to download that, or even if you didn't, you want to watch that and download this. It's very informative. It's very intense. I have to warn you, if you didn't see the class, it's intense, and for newbies it can be very overwhelming. So in fact, one guy asked me, he says that kind of scared me a little bit. I don't know if I would have dared buy the machine before, if I had watched that. So just so you know, if you're brand new, you obviously can go, really deep into that well. But at the same time, if you start off with a window of feeds at about 120 inches a minute and RPMs at about 18 to 20,000 RPM, in wood, you're going to be okay. And you can always modify it. But when you get to the point that you really, really want to fine tune and get, the best chip load you can use that calculator that Milo put up here. And he taught this class. It was excellent. Anyway, we're back to display case. And so I am now going to, I'm going to open up CCam Pro or Conversational Cam Pro. And if I go to File and Import Project, then I can go to my downloads, and there is my display table export. And so I'll just open it, and it says it's been saved as display table 1. And that's because I already had display table in here. We built it last week. So this is display table 1. It's just a copy, but I wanted to show you the technique for bringing it in. And if we open it up, of course, it's got all the parts that we now I'm lying to you. Okay, it didn't import all the parts. It doesn't look like. All right, I might have to check this because it should have imported all of the parts. Maybe, and it's possible I actually had deleted those and exported the wrong one. So from my other computer, and I apologize. Anyway, I will fix that so you can download the regular one, or you can build it like we've done here in last week's class. Okay, so we're going to be working in the display table, the one that we started with. And it has a turning center, and we created the part for the display legs. And so if we look at that real quickly, I'll just, whoops, let me get out of there. I went back too far. Let's go to the turning center and manage the parts. This is the display legs, and we made it 28 inches long, and it's 1 5/8 inches by 1 5/8 inches, 4 sides. And I made a note here that the blank is actually going to be 29 inches long because we're going to burn 1 inch. And the comment was also made that you might want to burn 1 inch at the far end too, at the tailstock end, in which case you would program it for 28, but you could make the part 29, okay, or 30 rather, 1 inch at each end, or however you want to do it. So anyway, we created this part. We also went into the vertical table and we created this display table rail. which is 8.7 by 4 by 0.75. And of course, when we put it in the vertical vise, it's going to stand up. The W is going to be your y-axis, and the T is going to be your x-axis. L is going to be the Z, which in this case, we really don't care about. Okay. And when we went to the horizontal table, we had a tabletop. In fact, let me go here and open that up. So here's the tabletop, and it is 12 by 12 by 3/4. And we also used the read a blank from our database, which we stored the display table rails into. And so this 8.7 by 4 by 0.75 is exactly the same. So we were able to use that part in both work offsets and both workstations. Sorry. Okay. Let me see if there's anything. So yeah, what else I want to do here is if we go into Aspire and I open an existing part, I again can go to my downloads, and there is the display table, and I saved it as VCarve Pro so that if you don't have Aspire, you have VCarve Pro, you can still open it. So everybody can open this now. It will require the latest version. That's the only caveat. Okay, so here, in fact, let me go in and show you how I've organized this. So you can download this file and have everything. So my very first layer, I put everything in different layers, is the assembly that we drew up last week. Okay, I also added the tools. And so this has, let me just zoom in on this, has the end mill, has the roundover for treatment on the tabletop, the V groove for the lamb's tongue, has a 1/4-inch core bit for the flutes, has the surface planing to machine it square and round, and also the classic spiral that we use on the leg. Okay, so those are all of our router bits. Okay, the next I added the parts, and I'm going to close this out real quickly so we can zoom to everything here on the screen. So here are my parts. That's the table, of course, the rail. This is 3 versions of the rail, just the plain rail, the tenons cut on the vertical, and then the arc we're going to cut on the horizontal. The blank that we're going to use for turning, plus the actual leg that we designed. And I added the end views, which we'll go over here in a second. Okay. And then I added, if you were going to put a 4-jaw chuck on it, that's what the 4-jaw chuck, this is the, I'm sorry, I got this mouse that's really overactive. Okay, this is the 4-jaw chuck. It's the record power SC3s. These are the dimensions. Yours might be different, but I measured and I can insert a 1/2 inch into the jaws. Okay, so I decided to set the x-axis 0, 1 inch from the end of the blank. Okay, and if we turn on the dimensions, you can see that the program starts at x0 is 28 inches to the end, but the overall blank clear back here inside the chuck is the 29 inches. Okay, so that's how I set it up. I have positioned the x0. I used the laser and set the x0 to this point right here, 1 inch from this end of the wood.
Tracy, this is John.
Yes, you bet.
Did you set the reference point 1 inch too? You know, in the original setting when you set up the length in Aspire, you set up the length, thickness, and all that, and then you set up where you put your reference point. Did you move that in an inch, for curiosity?
Okay, this is Aspire, so this is how I drew it. Now, when we drew this part, I have added this inch right here. So this is going to be left square, this section here. And so it's going to start. Oh, you're right. I see what you're saying. Okay, John, you caught me. These dimensions are all, no, these are correct, because our 0 is going to be right here. Our 0 is going to be right here. I have programmed the machine, and when we switch over the menu, I'll show you. I have put the 0 again out here on this part of the stock. So I don't care what's happening inside here, and everything is measured from this edge out. Okay, does that make sense?
Okay.
Yeah, I thought maybe I made a mistake there, but then I realized that I'd only made 2 mistakes in my life, and both times were when I thought I was wrong. So, sorry. Okay, bad joke. Let's get out of there.
You
All
and
right.
Chuck Norris.
All right. Now I also built a
That
hidden
was
layer.
popular in the 30s.
Okay, I'm not quite that old, but I'm pushing. All right, I turn on the hidden layer, and you can see here, I put this in blue. And so if you're looking down at the tabletop, you can now see the legs and how the joinery is actually offset. It's not centered. And then this is the rail that's going to tie this all together. All right. And down here, this blue is the end of the rail as it's going to butt up against the face, just to show us where the tenon's going to be. All right. So that's how I laid it out. Of course, I put the router bits on here so that you could, if you want to change your router bit, you can turn this on. But I like to turn it off because then it's much easier for me to manipulate. If I go to view, zoom, drawing, it'll basically bring everything in here. Right. So the next thing I want to go over is this view right here. So this is actually looking down from the top. As I programmed, this is a top view. But whenever you do a drawing that shows the end view, top view, and you wrap things around. So if you were to take this far end down here and push it back and bring this end toward you, so you're looking at this end, this is how you would be looking at it. So this is actually that cut right there. And then on this other side, the top side here is going to be this one. And I put it in here as 0, 90, 180, and 270 degrees. That's how Conversational CAM is going to position this. So if the part happened to be round, as you can see from here, this is looking at across the top view, that top is going to be 0. And if you wanted to go 90 degrees, you would go 90, even though it's round, 180. So if I was going to do a 3-legged pedestal and I might want to have joinery in here, mortises or dovetails, I could put it at 0, and then at 220 to 120, I'm sorry, and so on. So you divide it by 3, take 360, divide by 3, and that's where it's going to come out. So you treat this indexing, it doesn't matter if it's round or square, you treat it exactly the same way. So this view here again, and I apologize, my mouse is overactive and so it's zooming in and out too fast. But this view right here is this, if you took this one and bent it back. But in reality, if you were to look from the end, the operator end at the end of the machine, you would be looking at this part right here. And so you can see that the Y0 is in the 0. The Y0 is in the center of the blank. And anything to the right, this is from the operator end, is going to be negative. Anything to the left is going to be positive. Okay. And so when we programmed this tenon, which we'll do here in a minute, it's going to be a negative dimension. Okay. And we actually put it in the drawing last week. We drew it up, and I apologize, this is crazy. So we drew it up. Here's the center line right here, and we moved it over 0.125. So this is going to be a negative value because we want to make the tenon on the right-hand side of the center line. Okay.
Tracy,
Why
are your coordinates counterclockwise? I don't see that, 0 and then 90 to the left and so on.
Oh, great question. And the reason being is because from your operator end, when you're looking down the part right here, and you rotate the A-axis clockwise, it's going to turn clockwise like this. And so clockwise is a positive. And so if you rotated a positive 90, this side here is going to rotate up, okay, because it's turning clockwise. Does that make sense?
Yep, thank you.
Okay, no problem. All right, and so we showed y-axis positive and negative, and of course x-axis is 0 at the end and positive all the way down. And when you're rotating an a-axis, clockwise is positive and counterclockwise is negative. All right. All right. Are there any questions now on the drawing? And again, you can download this newest update. It's the same link. I just updated the link. So if you want to access this, go ahead and download. You have any questions?
Did you make the blue lines?
Yeah. Okay. The way I made the blue lines is if I took this tabletop right here, for example, and I right click on it and I say, move this to a new layer. In fact, I'll move it to a new layer and I'm going to call it top. okay, then you can choose here the drawing color. Or if you say, okay, and we go look at the top here, I can click on the screen here and I can change the color to orange, for example. Okay, so now when I click away from it, you can see the tabletop is now on its own layer and it's orange. So I assigned a color, as you can see here, to each layer. Okay, so I'm going to undo what I did. I'm going to take this and I move it back to the parts. And you notice it turns back to black because that layer is black, not orange. Okay, so for each layer, I wanted to divide them up, make them easy to identify, and that's why I used brown for the chuck, red for the X0, blue for the hidden parts, and green for the things, and so on. This is a real nice way to organize layers and colors. Okay, well, if everybody follows this, then we're going to talk tonight specifically about the indexing, mortising capabilities of CCAM. And I've got Mike Resch in the class here with me because if I make a mistake, Mike is going to correct me, right? Let me set up these advanced sharing. So just in case Mike wants to share, or if I need to share the screen on the Delta. All right, so I kind of want to give a shout out for Brad, who is programming this and what he's working on right now. This is an update, and I apologize, I can't show it to you right now because it's not available, but what he is doing is he is adding into Conversational CAM, when you go into a project, let's say we pick this project, you'll have a button that will let you collect photos into this project. And so we could take this and we can export all of these or parts of these as PDF files, okay? You can export them as PDFs. And then when we go into Conversational CAM, you're working in the project, you can import all those pictures. It can be a JPEG, that you take off the internet if you want, or a picture that you take with a camera, or it can be a drawing that you change to a PDF. You'll be able to collect those all in here, and you'll be able to assign each one of those pictures to a workstation. All right. So unfortunately, I can't demonstrate it right now. We were just working on it last night, but as soon as it's ready, I will demonstrate it. But it's going to be real handy because then when we go into our turning center, for example, and we go to display our table leg, when we say manage a toolpath, and we'll say indexing surfacing, multi-sided surfacing, then, and we select this, then it will actually bring up, I have to put that away for right now, that's the help screen. It'll actually bring up the photos, and it'll put right here on this screen, or the drawings or the photos of the part, which will be nice because I could take just this drawing right here, these elements, and I can save them as the leg. So instead of switching back and forth between my drawing here and the program, I'm using Control Tab to switch back and forth. Instead of doing that, the drawing will be built right in here, and I'll be able to scan through several of them if I need to and enter all the information directly from the drawings. So that's I'm really excited about that because I hate drawing and then flipping back and forth because I can't see what I'm programming and the parts at the same time without splitting the screen or having two screens, but that'll fix this. All right. So this is the indexing mortising, and we have to do this before we cut the joinery. So let's just start real quickly by clicking on the tool here, and it's going to bring up the tool selection. And I'm going to go to surface planing, and I'm going to use the standard surface planing bit. Now, the reason I choose this cutter is because I use this bit a lot for surfacing and for turning. I have to use it for turning because it's ground flat on the bottom. So it's the best cutter there is for turning parts round, which we're going to do later on this part on the leg. We're going to machine a tapered round in another section. So I'm going to use this router bit for both surface planing, the four sides, and for turning around. Okay, and I'm going to use the default. This is going to be our first tool. So the default here in the list of router bits is number 1. I can change it in the profile there. Last time it was used, it was assigned to 1, or I could click in here and type in, I want to use it to be tool number 3, but I'm gonna go ahead and just use this default. And so now it's tool number 1, and we can change that later. Okay, and now you can select the part, and this is this part has 4 sides is what I'm going to machine. So if it was a round blank, I could machine it to a 3-sided, to a 5-sided, to a 7-sided, whatever. Or even if it's a square blank, I can machine it to different sizes. But this is a square blank. It's already square, and I'm going to just work with that. And here you can say, we can select which side we're going to machine on, if we only want to do 2 inside sides, or if we want to do all sides, which we will do in this case. Now, as we go through this, you'll see right here is there's a help file that will tell you what you're doing with this particular field. And this says select this side you want to surface, and we said all sides. Now, when I click on section thickness, it has a caution here. It says can be a little bit different. This caught me off guard the very first time, but it makes perfect sense. It says the section thickness is measured from the material surface to the center of the piece. Okay, so if it's square, you would think that it's the full thickness of the blank. It's not. It's from the center to the surface. And if you think about it, if you had like a 5-sided part, then no matter how you turn it, it's turned around of it, the surfaces on the flats are going to be different than the peaks or the corners. And so you always want to measure from the surface of the blank to the center line. And so we're going to say here that the section thickness is 1.625. Okay, that's the original blank. And then it says, what is the starting position for this? Now, because I have burned 1 inch, as you see right here, I'm starting clear down here, I can go to 0. So I'm going to tell it the starting position here is 0. And what is the thickness at the starting point? And again, if we look at the instructions here, the thickness is measured from the material surface to the center of the blank again. I say, okay, so I'll make sure that okay. And I'm surprised Mike didn't jump in here. My section thickness here is from the surface to the center is not 1.625, it's half of that. So it's 0.8125. Okay. See, I caught myself. This is what happens when I talk and teach. I always screw up. Starting position is going to be 0.
Tracy,
And yes.
does that have a calculator like Aspire does, where you could just put divided by 2?
Unfortunately, not yet. Okay, I think that's an awesome feature, and I would like to add it in, but right now it's not. It's simply you put the value in. Okay, so the thickness at the starting point here is going to be 0.75. We're going to machine it to 1 3/4 inches. The end position, and again, if we look at the drawing here, we're going to measure it, we're going to run it square down to 4.5 inches right here. And then we're going to turn this section around and we're going to taper the section, but not today. Today, we're focusing on this section. Okay, so 4.5 is our dimension. And the thickness at this end is also 0.75. There's no taper on this at this square. So they're going to be exactly the same. Now, the rough pass step over, this is actually the same values that are used when we turn around. And this is a little bit different. And we'll probably make corrections here. You can overwrite any of these, but I'm going to make it 40% of the cutter, which is 0.5 inches. Okay, so it's less than the radius of the cutter. And the feed rate here, we'll put it at 100, or we might push it up to 120. I'll leave it at 100. And here for the finish, I'm going to do the same thing, 0.5. Okay, we'll probably change the defaults to something like this, and it'll list a 40% of the cutter that you select, and that'll be its default. But in here we had other values, so we'll make some changes here, I'm sure. Okay, and I'm going to feed rate. If I want to, I could put it slower for the final one because I'm not roughing off. In fact, I'm going to put 100 for my finish, and I'm going to put 150 for my rough passes. And then the pass depth is going to be 1/8 of an inch per pass, and that's cool. And my Z clearance, I'm going to increase this. I'm going to make it 1 inch, make sure that it clears the part when it rotates. Okay. And then we'll just click on, let me move this guy out of the way. Okay, I'm going to click on finish and save right here. And if you want to see the code, you can click
Hey,
on the
Tracy?
generate.
It's John, go back to the comment on that last thing you set, the 1 inch, because I was reading that thing and it says that, I'm trying to see if it's calculating that.
Okay.
It says it's, nope, yeah, right there, the Z clearance workpiece that you want the cutter to be when positioned for the next cut. So it doesn't take into account that it's not, that it's spinning.
Yeah. Yeah, when I'm turning around, it's only 1/8 of an inch, and you're going to put this value in. But when it's square, I don't want to catch that corner when it rotates. So in this particular case, I set it at 1 inch.
Okay,
And it's possible for us to take that router bit, or no, not the router bit, I'm sorry, the square blank, and calculate the swing diameter and add 1/8 inch to that maybe. And so we could have a default value in there. That's something that we could add, which I think would be very powerful. It'd help out quite a bit because
thank you.
this, we would want to catch anybody by surprise. Okay, so now we're going to finish and save. And again, we can generate our G code. And this, by the way, is set up for the Delta. If I had chosen under the database, machine database, and I had a Maverick 3x5 right here, then it would have generated code specifically for the Mach 3 system. Okay, so it depends on which system you choose. It'll run on both.
Hey, Tracy, would you mind clarifying which of the CCAN toolpaths measure the cutting bit from the center of the bit versus measuring from the edge of the bit?
Yes, yes, absolutely. It's when you're using the surface planing bit for turning around or for machining a surface like we're doing here. There is one other one, which we're going to use in a second. When we do the mortise, it'll actually use the edge of the cutters, and it'll explain that in the instructions. So
Thank you.
Mike's done a great job. When you go through all these toolpaths and you're adding the dimension in, he's going to inform you whether it's the center of the bit or the edge of the bit. Okay, so he's built the help all into it. He's done a heck of a job.
Great, thank you.
All right. All right, so far this has nothing to do with the joiner, but this just prepares us for the joinery because it machines that part square. Next, we're going to manage the toolpaths. Here's what we want to get to. We're going to use indexing, and we're going to do mortises and select. All right, now this is supposed to see if you have Adobe Acrobat Reader. And if it is, it's supposed to put the help inside the program. And if it doesn't, it tells you load it. However, Adobe has changed. We found a problem. Adobe has changed their download. It doesn't put it in the same location. So even though I have it here, it's automatically opening it here, which is irritating. And you might see this depending on your version of Acrobat, Adobe Acrobat Reader. But this is something that we will address. But right now, I just have to minimize that. It should build it in here when you click on Show Toolpath Help. It shouldn't bring up this window. It should put it, we're going to hide it. It should put it right here in the screen for you automatically. And it does on my other system, but not on this one. So that it's something that you may be caught by surprise, but just be aware if it does, just minimize it. All right, so we're going to do the mortising. I'm going to click on the cutter up here and select. And I'm going to go to a down cut end mill, and I'm going to use a 1 inch lane. All right. Now, the only reason I use down cut is so that it doesn't tear out the grain. You cannot drill with this bit, but it's going to cut a nice flat bottom, and it'll put the chips down below. You know, you will have to blow the chips out of the mortise when you're done, but it won't tear out the grain on the top surface. In this case, it might be irrelevant because you're going to cover that with the rail, but this just ensures that we're good to go. All right. We're not going to tear out the grain. So that's what I'm going to use here. And it has all the information I need here. I'll go ahead and just select it. Now this one says the default inside the cutter is 2, but the last time I used it is 1. Last time I used it is 2. And 0, 2, or 2 is the same. It doesn't matter. And so I can put a value in here, 3 if I want, and assign that one. Or I can just say, hey, use 2, which was the last one that was used, and that'll be fine. Again, if I go back into that bit and look at the cutter, then the tool number is right here. So if you wanted to change the default for the tool library and assign these that you'll always use, you can. Right now, they're all assigned as 1. And so you can just select that one, or you can change it and you can use the last one or add your own, which is really quite handy. Okay, now tool compensation. This one is set up the way that Mike has it set up. And again, the help is right here. Enter the difference between the measured tool bit diameter and the stated diameter. So if you have an inch cutter, or excuse me, a 1/4 inch diameter, which I have, and you measure the bit, you may find that it's small. Typically, it's smaller, and it's smaller by a few thousandths. And so normally this is going to be a negative number. Now, in a mortise, as you make the negative, the compensation negative, it's going to enlarge your mortise. Okay, so this is one way to make a test cut and see if the tenon fits the mortise, or vice versa, is to play with the tool compensation. I'm going to put in here a negative, maybe 0.05. So, excuse me, 0.005, which is only 5/1000ths of an inch. Okay. And you can experiment with this. I always do a test cut before I do it in a final piece anyway, just to make sure everything's correct. But we're going to use that 5/1000ths offset now.
Tracy, does 5/1000ths end up making the pocket 10/1000ths larger?
That's correct.
Okay.
Yeah, because it says well, Mike, you might want to jump in if I'm not mistaken, but it'll push 5/1000ths on each side, as I understand it. Okay. All right. Now here's the enter the A-axis degrees. Mike may be using chat to come to think of it, because he may, let me look real quickly. He may not have audio on his computer, or microphone on his computer.
No, I've got audio. I just didn't have it turned on.
Oh, okay.
That value, the tool compensation value, is applied to the diameter. And then when I make cuts, it's on the radius of the tool bit. So the 5/1000ths would be the total difference in width of the mortise.
Okay, so it's not going to be a 10/1000ths. It's going to make it 5/1000ths wider. Okay, great. Thanks, Mike. Okay, enter A-axis degrees. Now, this is where, if we go back to our drawing, it doesn't matter if it's round or square. Okay. Again, we're going to look at these bottom two, because this is like looking at the end view. So 0 is at the top from the end view. And so if we put 0, it's going to cut on that surface. And we just machined it square, and it's going to return it back to 0 degrees. So side 1, if you will. And so when we cut this first one, we'll cut right here. And then we're going to cut a second one at 90, so that it rotates it clockwise, and it'll push. So it'll cut on the left side here, and it's going to, we want to push that down. We don't want it the same offset on the same side. So Mike has already thought this through as well. And this is brilliant. I love this. Let me show you how to do this. And it actually shows this in the help. If you click on the show toolpath help, it'll explain all of this. But in the enter the A-axis degrees, I'm going to put 0. And in the original conversational cam, I would put 0, and then I would create a separate toolpath, and I would say 90, and I would push the Y-axis to the other side. You'd have to create 2 toolpaths and set up both of them. Mike has made this dead simple. You put comma, and I'm going to put 90. So now it's going to cut the 2 mortises, one at 0, and then it's going to go right to 90 and cut the second one. And if you put an M here, it will mirror that. Mike, does it matter if it's upper or lowercase? Okay, I'm going to assume.
I don't think it matters.
I don't think so either. I seem to always have used the capital, but so you just put an M in here, and that says you put it at 90, but mirror the offset, which is perfect, because if we go back and look at the drawing again, let me go in here. All right. So if we just rotated this up, this tenon would be here on this side, top side, but because we're mirroring it, it's going to push it down. when we rotate, it's going to be positive y, but when it's up here, it's negative y. Okay. All right, so that is brilliant. I love it. Now, next we're going to put in here is the section diameter. And again, this is the total thickness of the part, not the distance from the surface to the z-axis. So this one we're going to put in here as 1.5. Oops, I'm sorry, I was in the wrong field.
Tracy?
Yeah.
This is John. I got a question on mirror, the 90 mirror.
Yeah.
If one was offset, but then the other side was in the center, let's just say it was. I know that's not your drawing. You'd have to do 2 of these.
Yes,
is
you'd have
correct.
to do 2.
Yeah,
Okay.
you would.
Okay.
Yeah, good point, John. Thanks. Okay, so this one is the section diameter because it's already turned around or it's square. So we're just going to go to the 1.5. Now the x-axis start position. Let's look at the drawing. And the x-axis starting position yeah, Mike, this is to the edge of the router bit, right?
Yeah, that's wherever you want the hole to start.
Yeah, so if we look at the drawing and we measured from the starting of that hole, it's 0.5. So that's the value we'll put in here. And for the ending, the outside of the bit is 3.5. So this is a case where it's going to the outside. But he's just saying whatever that mortise is, that's where it's going to start, that's where it's going to end. So you really don't have to worry about it. Okay, so x-axis start is going to be 0.5. The y-axis start is going to be at a negative 0.125. Okay, and then this field here that I just passed is retract. Let's click on this. This one is used if you want to do almost like a keyhole slot. You want to do a sliding dovetail. You want to do something where it doesn't lift the bit out at the opposite end. Then you can retract the bit at the starting point. So when it cuts down, it'll cut back and then lift it out so it doesn't blow through. If you're using a dovetail bit, this is really important because you don't want to blow a hole through the dovetail slot. So, and he explains it here in the help. So we're just going to say, no, don't worry about retracting it at the start point. We can retract it at either end, doesn't matter. The x-axis end is 3.5 and the y-axis end is also negative 0.125. So
Can we
this
go back
I
and
found,
check? Can we check that? Can we go back to the drawing? I don't quite see it being 0.125.
0.125. Okay, yeah, let's go back to the drawing perfectly. All right, here we go. So this, I hope you can see this line right here is the center line, the Y0 right here. And if you look at this, here's the blank, but the mortise is offset. And we measured the center of the mortise in the y-axis to the center line of the blank, and it's 0.125. And if you watch the class from last week, you'll notice that when we build that mortise, we push it down an 1/8 of an inch. Okay, and then when we measured it, of course, it read the 1/8 inch. But that's the offset. It's just, and if you want to measure it here, you can go into drawings and go to dimensions right here, and we'd measure vertical. And you would simply measure from the center here to the center of the, sorry, my mouse is going crazy. Go to the center, trying to find it, right there of this, and we put it down here. Okay, this says it's 9/10 of 1/1000 of an inch different. So I may have missed it by 9/10 of 1/1000, but it's 0.125. Yeah, we can accept that. Okay,
Yeah.
good.
But I guess I see it now, but I was struggling with that 0.3 on the other end of the.
Okay, and you can see right here, when I drew this up, I made it 0.3 inches wide. And that's this dimension right here. Okay. All righty, and so that's why I put mortise width right here of 0.3.
Hey,
Okay, now,
Tracy, could you
yes.
go back to retract router bit at start? I must have been dozing or something. I missed something there. Is
Okay.
that like pick drilling or what do you have there?
No, okay, so this is cutting a mortise from along the x-axis, all right? So it's going to start at x, in this case, it's going to start at x 0.5, That's the edge of the bit. And it's going to go down to X 3.5, right? And so when you mill that mortise, you can start at one end, but if you cut the other end, do you want it to be able to retract there or not? And if you say no, retract at the starting point, you say no, then it will attract at either end, whatever it needs. But if you say yes here, it will only retract where it plunges in at the starting point. Okay, now this is typically used, like I say, if you were cutting a dovetail slot, like we did a 3-legged pedestal with a dovetail slot, you don't want to have that router bit lift out of the end of the dovetail slot. It would blow a hole through it. Okay, so you want to plunge in, cut down to the end, and then back, which is kind of a pain in the butt. But here it makes it real easy. You just say yes, retract, and we can do it here too if we want. We can just say yes. It won't matter in this case because it's irrelevant. Okay, so you could do it either way, but this forces it.
Yeah, it does matter because
so?
if you say retract to start, then it cuts the full depth of your mortise at the same time.
Yeah.
You can't do passes.
Can't do pass steps. Okay, and that would be for the dovetail cutter, correct?
Right, that would be for the dovetail cutter. You don't want it to do passes. You want to do it to full depth whenever it cuts.
Awesome. Okay, great.
So is that going to cut the whole depth straight across at 3.5 inches?
It's going to cut it 3 inches long, and it's going to do it in a pass depth right down here. If we've got 0.25, that's the default. So it's going to make one pass at a quarter of an inch, then it's going to go down another quarter of an inch, then it's going to go down, as many passes as it needs, quarter inch at a time, and that's controlled by the pass depth.
Okay, I see. I was tying the two together. I get it.
Yeah, if you put yes, then it overlooks this pass depth. Is that right, Mike? If you put yes, retract
Yeah,
it,
it overrides the pass depth.
so that it cuts the full depth in one pass.
Yes.
Okay. All right. Perfect. Now, if you were doing, for example, a dovetail slot, and you were using a straight cutter to create a chip relief path, then you would say no. It could lift straight up. Wouldn't matter at all. Okay. And then it would do it in pass steps. But when you added the dovetail router bit, you said, yes, retract from the starting point. It would overlook that 0.25, go all the way down, and the dovetail bit would move down and back and then straight out. Okay, I hope everybody follows that okay.
So
All right.
You'd have two tool paths, one to run a end mill down to clean it out and then come back with a dovetail.
That's correct. It would be two separate tool paths. That is correct. All right. Now, the one thing that Mike's building here, which is, again, brilliant and beyond what I had originally had in mind, was you notice the y-axis start, in this case, is a minus 0.125. And here in the end, it's also a minus 0.125. But if you put this a positive 0.125, that mortise would cut on a diagonal. All right. So it doesn't have to be straight. It can be offset. It can be diagonal. It can be all over the place. It's pretty cool. All right. So let me see, the mortise depth, we got the width. Now we're going to put the depth. The mortise depth, we're going to put, and I put this on the drawing, but it's, so we could go look at the drawing if you have any questions, but it's going to be 5/8 of an inch deep. The tenon is only going to be 0.6. So we're going to leave that 0.025 inches of gap for glue. All right. And here you can auto calculate, or you can input your step over. Here you can input your feed rate, or you can use defaults, but we're just going to input them here. I'm going to slow this down a little bit because we're cutting aside that mortise. So I might make it 100 or maybe 80 or something like that. You can run it fast, but it might scare you. Okay, so I'm going to run a little bit slower. Pass depth here is going to be 1/4 inch. That's the diameter of the cutter, so that'll be fine. And again, my Z clearance, because I want to rotate the blank, I'm going to put 1 inch here, so that when it lifts up 1 inch and it rotates the blank, I don't catch that corner. And then I'm going to click on finish and save. All right. So now when I generate this G code, you're going to see it's going to machine it flat, and then it's going to cut the mortises at 90 degrees, and they'll be offset automatically. So let's go ahead and save this. I think we want to go ahead and cut this, set up and cut it while we have time. We'll have to, looks like we might come back and do the tenon on the rail in the next class, because we're taking up more time than I anticipated. So anyway, what we can do is we can save this, And let me see if I've got a flash drive. Okay, so I took the flash drive and put it in the system. So I'm gonna share my screen on this other system here. Okay, so this is my controller, the MP1 computer for it. And I have homed the system, and we're going to be working on the turning center. So I'll click on the turning center here. And we've already set up the 4-jaw chuck here. And you notice that if I tell it to go to the offset, it goes to the original setting for the 4-jaw chuck. We're at 0, 0. But I have also set up a 4-jaw chuck with a 1-inch offset because that's how I drew this up. And so you notice this one, the X is off, well, essentially 1 inch. So now if I say move to the offset, it's going to move it down 1 inch to 0. Let me see if I can show that on my system here. Okay, so let me take control here. If I lower this down, you can see we're 1 inch out in front of the part. So this, I set up 2 offsets.
Okay, I've got you, Tracy. Never mind. Sorry.
Okay. And again, that's how I drew it up, with X0 out 1 inch. So I created a brand new offset called the 4-jaw chuck with 1 inch. So I could use that. Right now, what we're going to do, I'll raise this back up, and I'm going to go ahead and step around and put the blank in, and then we'll start cutting the part. Okay, so a couple of things. I'm using the 4-jaw chuck, obviously. At that far end down there, I took an awl and I just eyeballed it, and I put a hole in the center of it. Okay, that part's going to be tapered, so if I'm off a little bit, it's not really critical, but I got it centered the best I could. When I tightened up the handle on the tailstock, I rotated until the part was secure. I don't want to over tighten it, so I just brought it up till it was, wouldn't move, and then the handle was straight up. So I disengaged the handle and I rotated it down out of the way so that I can clear it. Right. So at this point, we're all ready to go, except that blank may not be square in the machine. So there's a couple of ways you can do it. I can side off the tailstock and just see if that surface is level. We're gonna remove some material, so if it's not perfect, it's okay. But I'll show you one trick that I used that was pretty simple. Okay, so I can just put that part across and I just line that up with the tailstock and I can see that it's not straight. So I'm going to go into my I'm going to go into my system here and share my screen so you can see this. Okay, so what's going to happen is I'm going to go into step jog. I'm in turning. I'm in the 4-jaw chuck 1-inch offset. So the smart tool is good to go. We don't need the vacuum table. I'll turn that off. We can rotate it very carefully a couple of ways. You can either put a jog feed rate in here of like 10% or something. And so when you jog it, it moves very, very slowly. Or you can put a step jog. Now, when you're rotating and you step jog, this is in degrees. And so this is 1/10 of a degree. It's barely going to move, if anything at all. When I rotate it using the A-axis right here, it's barely moving. So I could increase this to 1/10 of a degree and rotate it. Or even 1 degree. Okay.
Hey, Tracy, it
Yeah.
appeared that at a 10th, it didn't move, or at one, your first two didn't move at all.
Right. You're right. It didn't move the A-axis register. So it was too fine of a degree. And so I stepped all the way up to 1. I pushed this up to 1 degree and then it moved. And then I pushed it back to 1/10 of a degree and that worked. Okay. But if I push it down any farther, it's just too fine. It won't move at all. Okay. Now, you can't see this, unfortunately. I don't have a computer on there, but the board actually rotated until it's level with the tailstock. And if it's not perfect, it's okay, because we're going to remove a little material, but that'll get you there really close.
Do you want to zero your axis though? Your A-axis, so it's zeroed?
Yeah, that's a good question, because you can zero it right here on my screen. I can simply click on the A-axis and it will zero it. But if we look at the code, let me load the code real quickly and we'll take a look. Okay, and again, I'm going to share my screen. Okay, so here's the part right here. Again, I went to open and went to the E drive, which is my flash drive, and it picked up the display table, leg, square, and mortise. That's the one we just created. Okay, and we'll open that up. Now, if we go down through the code, I'm just going to scroll down through here. You notice that once it changes the tool, sets the height offset, which in this case is 0, or adjusts the height offset rather, in this case, it turns the spindle on, and then it sets the A-axis to 0 automatically. So if you don't set it, it's okay. It's going to set it for this point. So it says this is our beginning position, and then it's going to go ahead and machine. Okay. So what I'm going to do is I'll go ahead and I'll just click cycle start here, but I'm going to flip over so you can watch the camera before I do that. Okay, and one thing that is critical is that you have to have, in our code, we had tool number 1 as the surface planing bit, and I'm using an auto tool change system, so that's got to be in the proper tool station. And tool number 2 is the 1/4 inch, so it has to be in the proper tool station. So we've got that set up. I'm going to go ahead and I'm just going to click cycle start. Okay, so maybe I'll get out of the way. It's putting tool number 2 away. And I just realized I've got a problem, so I'm going to stop this. Okay, I just hit reset to stop it. And what I had neglected to do was to turn my smart tool on. Whenever you're turning, you want to use smart tools so that it automatically sets Z. It's got the proper tool in here now. So if I go into smart tool, I'm just going to do it on the screen here, and I turn smart tool on. Then I press cycle start. And I've got this in my way. Let me move this. Okay. And I start the program, it's going to go touch off the smart tool and set the Z properly. If I programmed it properly.
Hey, Tracy, while we're waiting on that, I do have a question. On the CCAM Pro setup for the auto tool change, it says 7 stations for the tool changer. Does that, I changed it to 6. Does that matter?
Hey, Chris, I can only see your face. I can't see what's going on with the turntable.
Look at the little things under Tracy Anderson, little squares, you can see it.
Double click on that little square and it'll enlarge it.
Okay, I apologize. I couldn't hear while that was cutting. So I know there's some questions, but so it cut, as you saw, the 4 sides. It's going to go pick up tool number 2. And you also notice that it rotated back to side 1, which was 0. Which was at 0 degrees. Okay, so it's going to touch off smart tool, and then it's going to come back and cut our mortise's offset.
Tracy, is this pine?
Okay, we'll let that shut off so I can hear again. Okay, go ahead.
Is this pine that you're cutting?
It is. So this is just a sample blank that I can test on. And once we get everything worked out, then I will I'll probably do it out of either maple or walnut, and we'll build the final part. But I like to test everything in just whatever I have, garbage wood. So this one here is pine. When we go to cut the tenon, I'll probably just cut it out of MDF because I got some material laying around that we can practice on. Once we know everything's good, then I'll come back and cut all of the parts, using our finished wood.
Tracy,
Yeah.
is there any control on the plunge rate?
Let me take a look real quickly. Okay, tool compensation. Feed rate 80 past dip. I don't see a Z-axis plunge feed rate control. This is and this might be the same feed control on all passes, Z-axis and the linears as well. Mike, if you're still in, maybe you could clarify that. I don't know. I didn't notice to see if it was plunging at 80 inches a minute, but it was cutting everything else.
In the tool, there is a feed rate and a plunge feed rate. So I'm just wondering if it stays with the default plunge feed rate.
That's a good question. So if we go in here to the down cut, and we were using this particular one, yeah, there is in here a feed rate, which is 150. We overrode, of course, that. And there's a plunge feed rate of only 40s. So I'm not sure if he's using the 40 that's set in here, or if it's using the 80, or if it's something different. So I'll check with him and verify and find out.
I think I'm using whatever feed rate you have in the template.
Okay, so that would be then the 80 right here under this feed rate. Okay. So we may want to, yeah, so Mike, we may want to add a plunge feed rate to control to it as well.
Kind of on the same note, do you have peck drilling in here? I didn't know if it did or didn't.
Well, it's not, no, there's not peck drilling here. Now, when it comes to the drilling toolpath, I'm not sure. I haven't used that yet, so I don't know. We'd have to check with Mike, find out if it's got peck drilling. But this one doesn't peck drill. It plunges and just cuts your.
Yeah, that's what I meant for like your drilling, not for necessarily for this, but in the program. I wasn't sure if you had it or not in the drilling portion. Yeah. I don't know either.
Mike, do you have peck drilling as part of that? I haven't tested it yet.
I think peck drilling will occur when you're drilling on indexing. And then I have also on a 3-axis, I have where you can drill shelf pins, and that's peck drilling also.
Okay. So I personally have a lot of testing. It's one of the reasons that we, started the beta program. So those of you who have the beta and those of you who are getting it, if you haven't got it yet, can give us some feedback. And let me just, again, go over that, our arrangement. Hopefully this is a win-win proposition. So if you fill out the form under submit customer showcase files and put in your work, and if you're brand new and you haven't done any work, just send a picture of you and your machine, and then you put a story that kind of tells what you have in mind or what you've done or a little bit about you, so that we can create a customer showcase about you. In exchange, you get the beta unit free to test and use. And then at that point, if you use the feedback, which is our website /CCAM, and give us feedback on that, and then use CCAM Pro to build something, okay? So that we can show pictures of showcase of what you've done with CCAM Pro. Then, and you've got this will go for a year, the beta will go for a year, and then it'll expire. But in the meantime, if you'll send us things that you've done in CCAM Pro, so that we can build a thing like that, you'll get a copy of CCAM Pro, the legitimate system when it launches, okay? And it's normally about $500. So hopefully this is a pretty good deal. If you're willing to share with us, we're willing to share with you, and we'll cover the cost of the program. We still pay for the program, but we'll cover the cost for it and just let you have it. Okay, well, we're out of time. So in the next class, let me just go back to, I'm going to share my screen here again real quickly. Okay, so what we're going to do next time is we'll pick up where we left off here, and we'll program the vertical stations so that we can cut these tenons. Again, I'm sorry, my mouse is very overactive. We'll cut these tenons on the vertical vise standing up like so, and show you that. One thing I want to mention here that's pretty exciting, we have a lot of school shops that are using the machines and making legs and things like that, and all of them use the domino, like Festool's domino machine, and it will cut mortises in the ends of your blanks or different things, and then you use what really it's a floating tenon is all it is, that's going to fit into the mortise here. So you would, in their case, you would put a mortise in both the leg here and also in the end of the rail. And then you use a floating tenon or the domino tenon to put in there. And you can get that at different sizes. But what's nice is that now you can combine and you can use that tenon. So if for example, you wanted a tenon on a very long part, or excuse me, a mortise on a very long part, and you can't stand up vertically in the table, then you could use that domino system to machine that. And then you can insert a floating tenon and join it up with something like this. So this makes a great combination between, floating tenons and the domino system, or you can do it all 100% in the system like we'll be doing here. So your choice. It's so versatile that you pretty much have all the options you want to address how you're going to use this in various applications. All right.
Tracy,
All right,
in that view where you're looking at the end of the leg.
Oh
and
yeah.
You said you had the tenon or the tenon or the slot mirrored. If you rotate that 90 degrees, they're off center.
Correct. Yeah. So
But they're in off center in opposite directions.
That's correct. So I'm going to rotate this A axis. I'm going to set my I'm going to set my jog feed rate real slow, maybe 10%, and then I'm going to rotate the A axis. Okay, so you can see this one's on the far side. This one's on the near side. Oops, went too far.
I see it. Yeah.
And so this is going to be your inside corner here. And so the rails will be on the outside of both edges.
Got it. Thank you.
Any other questions?
Yeah, you said to talk later, you were going to get to it about deleting toolpaths or.
Oh, yeah. Yeah. Okay, great. Let me share that real quickly. Okay. So it's a little, once you use this, it all becomes really simple, but everything is done. Did I not? Oh, I didn't select a tool here. Okay. All right, let's go back into here. I'm sorry. So you see here that I have no way to delete that. I'm just going to save it. I show them here, but I have no way to delete them while I'm in this view right here. But when I go into the display legs, for example, I can go to Manage Toolpaths, and this is where I could select one and then delete it right here. Okay. You can also select it and rename it right here. And so you can work with the various toolpaths. You can actually even arrange them. This is where you would make the arrangement, which one cuts first and second and so on, is in the Manage Toolpaths, the Toolpath Manager. And that's where you delete it. Okay.
Got it. Thanks.
Tracy, I submitted a question, and I understand why you haven't got to it. But quickly, the point is, I want to make a round mortise, actually on a round component, but it could be on the part you're doing tonight. And I don't see a way to do that yet in CCAM. So what I did was draw the mortise I wanted in VCarve Pro, and then I added a imported VCarve code to
sweet.
That. Is that correct? Is that how I should do that?
Yeah, absolutely. You're on the right track. That's again one of the advantages here is that we're going to collect everything and put it into one project. The pictures, the files, even G code that we've created in other programs like Aspire, we can bring it in. So you're exactly right. If you had a round leg and you want to put a round mortise in it, you just draw the hole, create the toolpath for that particular thing. And then when you go into your Manage Toolpaths, there is an import, and you can import that G code and execute it as well. So that's perfect.
Thank you. I'm gonna run it. I'm glad I could run it by you before I turned it on the machine.
Yeah. Now, the only thing that's kind of critical there, let me run by this real quickly, is however you drew it in Spire, it has to be set up correctly. All right, so I'm going to open a new instance of Aspire, and I'm going to create one real quickly. And we've gone through this a lot of times, but I'm just going to say it's 12 inches, and the width is going to be 1.5, in which case the thickness has to be half of that, 0.75, because we're going to the radius. And you have to have the Z0 on the machine bed like this, not on the machine surface. Okay. And then you use an offset and you move the y-axis a negative 0.75 as well. In this case, half the the square thickness, and you click OK. If you set it up this way, then any code that you generate to cut on here, when you load it into the system and touch off the Smart Tool, it's going to set the Y0 to 0 right along here, the X-axis right here at this end, and the Z-axis will be measured from the center of the blank, taken from the Smart Tool touch off.
Yeah, that's how I did it.
Perfect. All right, good deal. I'm looking forward to see how it works out for you.
Tracy,
Yeah.
when it comes down to Mach 3, is that just the difference of just choosing Mach 3 and setting your A and then hitting cycle start, kind of that simple?
This program, if you're using Mach 3 or Delta, this program will set the A-axis to 0 at the beginning of the program. Wherever you have it set, it will set it to 0. It doesn't matter if it's Mach 3 or Delta.
Okay, thank you.
If you have any questions, 0 A-axis before you run it, and then you're safe. But if you look at the code, like I showed you, if you see that G92 and an A0, that means I'm setting the A-axis, no matter where it's at right now, I'm setting it to 0 before I start cutting.
Perfect, thank you.
Hey, Tracy,
Okay.
real quick, on the machine setup, the machine database, the Maverick 4x8's got 7 automatic tool or 7 ATC stations. Is that the way it's supposed to be, or did I need to change that to 6, or did you guys upgrade after I bought mine and I just didn't tell me?
Yeah, we haven't told you, Chris. All right, so what you're looking at, if we go into the database and the machine database, and I'm choosing the 4x8, this is Gen 3, it has 7 workstations right here. Okay. Now you're going to use the 4x8 2020. If it's an earlier version, it only has 6. If I click on this, you notice it only has 6 workstations. So here's what we did recently. We found that we could add one more tool clip or one more tool station onto the machine by compressing it. And let me just jog this out of the way. Okay, I'll just home the machine. So you can see here, this one only has 6 workstations. This is the original configuration. We were able to squeeze that in and put a 7th one on. So we just started including it, and we didn't tell anybody. It was just a bonus for the newer machines. All right.
Hey, Chris, just buy a new machine.
Yeah, you know what? I think I might, but I've heard the cost might have gone up to reflect that 7th station. So I'll just use the 2020 if I've got the 6 stations then.
Yeah, do that. Or you can use the other one if everything else is identical, and you can just change the workstations to 7. So you can modify that any way that you want.
Okay, awesome.
Hey, Tracy, I thought I just heard you say you were going to home that gantry. Did you home it or park it?
I just parked it. I'm sorry. Did I say home? I apologize.
Yeah, because I tried that and it goes very slow.
It'd take you a week to get there.
That's right. It homes very slow. You're right. So I just parked the system, and then I'll shut it off. And when I start up, I want to home it. But yeah, if you home it from this end, it's going to take forever.
Why is there a tool number limit of 20?
You talking on the machine, or are you talking? What are you talking? The limit
in CCAM Pro, it says the maximum tool number is 20.
Yeah. And in reality, you're going to use 12. Okay. Now here's what we've done with the Delta system. Now on a Mach 3 system, you can use as many tools as you want, up to 253. Okay. You'll never do that, but it's possible. On the Delta system, we actually, maybe I can share this and show this to you. Okay, so if I go into the settings, and you all know that this settings password is 2020. Okay, and then we click OK. So we get in here. You see on this side, this machine has 1, 2, 3, 4, 5, 6 activated as auto tool change, has 7, 8, 9, 10, 11, 12 as manual tool change. So on this system, you're going to use up to 12 tools. Okay.
Hey, Tracy, excuse me. There's a special note that kind of came out that says you kind of need to get home to your wife. So let's call it a day for the class and take care of what you need to take care of in life.
Yeah. Good night, everyone.
Good night, Tracy.
Okay.
Thanks, Tracy.
Yeah. Okay. Appreciate that very much. I'll see you guys next week then.
Okay. Thank you.